So let's rewrite this problem. Instead of the exponent 1/2, I'm going to use the radical notation. So in the radical notation, I have 3p plus 13. Let's put this under the radical sign. The square root symbol is being very specific because radical could mean a square root or a cube root. In this case, it is a square root. So on the other side, we have 8. So in order to solve for p, we have to get it out of the square root sign. So we do the inverse of square rooting, which is squaring. So let's square both sides. So squaring both sides. So this will give me 3p plus 13 under the radical symbol. And I'm raising the entire thing to the second power and do the same thing on the other side. So now when you raise a square root to the second power, the square root and the exponent to cancel each other. So now we have 3p plus 13 equals 64. So let's subtract 13 on both sides. This gives us 51. And on this side, the 13 plus 13 and the negative 13 cancels. So 3p equals 51. Divide by 3. And this gives you p equals 17. So let's check our solution. So in order to check, you have to substitute your answer in the original problem. So let's do that. 3 times 17 plus 13. So in the original problem, I have 8 on the other side. If we get a true equation, then we can conclude p equal to 17 is the solution. So this is 3 times 17 is 51 plus 13 under the square root symbol. So now we have a 64. We are trying to see if this is equal to 8. So yes, the square root of 64 equal to 8. You know that the principal root or the positive root of 64 is of course 8. So this is true, which helps us conclude that p equal to 17 is the solution.